meteorological techniques for climate smart agriculture. On behalf of Center for Advanced Agriculture Science and Technology for Climate Smart Agriculture and Water Management, Mahatma Phule Krishi Vidyapit Rahuri, I welcome to all the participants to this training program. First of all, I would like to request our principal investigator and convener of this training program, Dr. S.D. Gorontiwar sir, to give preamble of this CAAST project.
Thank you very much, Dr. Conade. I hope I am audible.
Yes, sir.
Very good morning to all the participants and the experts of today's morning session. Okay, so who have joined for 1 week online training program on advanced agrometeorological techniques for climate smart agriculture. So this program is going to start from today, that is 29 June, and it will be there till 3rd June 2020. Okay, so all the participants and the organizing team, including Dr. Andhre, who is organizing secretary, then Dr. J.D. Jadhav, who is head department of Agromet and also joint organizing secretary. Many of the participants, I think they know both our organizing secretary and joint organizing secretary, and at the same time co-convener Dr. M.G. Shinde, okay, and all others, those who have joined for this very short inaugural function of this 1 week online training program. Okay, so in fact, I would like to take this opportunity to tell something about our project as well. Those who already attended previous training programs, okay, I think they know about this project. In fact, the project is entitled as Center for Advanced Agricultural Science and Technology and Climate Smart Agriculture and Water Management. So in abbreviation, we call this as the CAAST on Climate Smart Agriculture and Water Management. This project is being implemented in Mahatma Phule Krishi Vidyapit Rahuri since last 1.5 years under the World Bank aided National Agricultural Higher Education Program of Indian Council of Agricultural Research, New Delhi. Many of those who are coming from the agricultural universities, they may be knowing that this NAHEP, that is National Agricultural Higher Education Program, is being implemented in many universities in one or other form actually. In Mahatma Phule Krishi Vidyapit, this is for the climate smart agriculture and water management. We have 4 objectives for this, and the important objective is regarding the academic. We have 3 academic programs designed for climate smart agriculture and water management. One is starting postgraduate diploma in climate smart agriculture, and that will be starting from the month of September. Second is to start the post-doctoral research program in climate smart agriculture and water management, which we have already started, and the details are available on the CAAST website. And the third one is to strengthen the MSc, MTech, and PhD programs of our university. So this is one objective. Second objective is to develop the technologies based on the recent advances such as geoinformatics, hydroinformatics, robotics, drones, Internet of Things, mobile applications. And the technology should be such that it should be farmers friendly, but at the same time, those should be precise, efficient, and also backed up by the real-time data as well, so that the farmer should be able to take some real-time decisions. We have already developed some pump controller, in which case the farmer's mobile fetches the real-time data of the climate, weather of his or her farm, and based on that, we run one simulation model. So that model enables us to estimate the crop growth and also find out what is the irrigation water requirement. And accordingly, farmer gets the irrigation water requirement based on the real-time soil, weather, and crop data, and also the data regarding to the irrigation systems. Okay, so this is considered as very precise information, and then that precise information is passed to the pump controller remotely, and farmers can start the pump from anywhere actually. So this is just one example. We have developed some other technologies and tools for real-time and precise operation in context of the climate smart agriculture. Our third objective is to develop the capacity amongst the researchers, students, faculties of Mahatma Phule Agriculture University and other agricultural universities in India. And with this view, many of you may be aware that when lockdown started, we immediately started our endeavor of engaging ourselves and engaging others as well. So, as a matter of fact, when lockdown started from 22nd March, on the same day we started planning. And then our first online training program was started in the first week of April, and that was on the digital marketing. I'm very glad to tell you here that so that was the first online training program ever conducted in India, because there used to be some webinar or one lecture kind of the things, but ours is the online training program. And subsequent to this, we have organized 28 one week, 2 weeks online training program, and this is the 29th one. And in addition to this, we also organized 6 webinar series as well, which are of the duration of 1 to 5 days. Okay, so in that process, we organized 262 training sessions of 1.5 hour to 2 hours each, and we reached to 10,000 participants, students all over India and abroad as well. And also, is to develop the climate smart villages and digital village approach using what are the technologies that we developed till now, or what are the technologies we are going to develop, and in that process also to provide some hands-on exercise training and case studies to the students. So in short, these are the objectives of our project. And so to satisfy these objectives, our organizing secretary, Dr. Anand, and joint organizing secretary, Dr. J.D. Zadov, proposed this training program. We received a huge response to this training program as usual. And this was very stupendous task for our organizing secretary and organizing team as well, including Dr. Kanade, Dr. Porse, Engineer Mohsin, to select the candidates. But nevertheless, we also started the process of, in fact, live casting this through YouTube, so that those who are not able to join and those who are still interested, they can take the benefit of this program. On this occasion, I welcome all the participants, including I think I see our experts as well, Ravi Patil from US Dharwad, and maybe others are there, so who contributed us immensely in our previous agromet training program. Okay, so with this, I would like to remain here. Thank you very much, and I wish all the best for this training program. Thank you.
Thank you, sir. Thank you for the brief introduction of CAAST project. Now, our today's speaker for this training program is Dr. Raju Chattopadhyay, Scientist E from Indian Institute of Tropical Meteorology, Pune. Now, I would like to request our organizing secretary, Dr. R.P. Andhale, sir, to give brief about this training program, and please introduce our today's guest, Dr. Raju Chattopadhyay, sir. Andhale, sir. Andhale, sir. Okay. Good morning, Dr. Raju, sir. Dr. Raju, sir, is a scientist E from Indian Institute of Tropical Meteorology. In context of research, he worked in neural network and machine learning in weather and climate research, then subseasonal prediction of monsoon using statistical and dynamic models, then bias analysis of global dynamical models, then tropical intraseasonal oscillations, then prediction and monitoring of monsoon intraseasonal oscillations. Uh, Dr. Raju sir is a postdoctorate fellow from University of Miami, US, and he is worked in IITM on different scales, that is scientist C, scientist D, and now he is working as scientist E. Now, on the behalf of all CAAST team and organizing secretary, I would like to request Dr. Rajiv sir to start today's session.
Okay, so thank you very much, Neil, and organizers for allowing me to speak in this very nice workshop. And there is a very great introduction given already. So I'll just start with my presentation here, and I'm just sharing my screen. So let's, yeah, I hope you can see my screen right now.
Yes, sir.
Okay, so yeah. So I work in the extended range prediction group in Indian Institute of Tropical Meteorology. Our group leader is Dr. A.K. Sahai, and he has not been here today due to some other engagements. So I will present the work on behalf of him, and mostly this is a overview type of work. So not only in what we are doing, but also just to give a glimpse of how monsoon variability and its predictions are actually now we can actually see in different aspects of life. But mostly I'll focus on the agriculture part here. So there are terms like seamless forecasting. The seamless forecasting is a very popular term right now. So it means that when we forecast something, we have to get an understanding of all the different scales of a weather system. By scale, I mean it can be a temporal scale or it can be a spatial scale. So we should have to forecast, say for example, a small block over India, or we have to forecast a state, or we have to forecast all India average as a whole. And also we have to not only we have to forecast it only over one particular region. We have to forecast on different time scale. So for example, different users need the forecast in different time scale for planning and preparation. Now, it is very well known that actually you cannot have a same set of forecast method or forecast model for every scale. Now, in this way, we are trying to actually see how multiple scales are forecasted. It is a gross overview of multiple scales of forecasting of monsoon. By monsoon variability, I mean not only that monsoon varies every day, day to day, it is varies from day to month to season, and it also varies from decades to decades. And as we all know that climate change has now become a very strong component of all the monsoon variability study. So basically, I'll first start the slides with the help of a overview of the climate change, some recent analysis based on the climate change studies. So, as I was discussing, one of the mandate of Ministry of Earth Sciences is to produce the weather-based climate science-based weather and climate information uh, that incorporates future climate change and impact of climate forecast to make a strong decision support system for applicable to different stakeholders. And the Indian Institute of Tropical Meteorology has programs on climate change, and we have another program called Monsoon Mission. Basically, these two programs are actually giving the overview of the research and operational applications of climate studies in different fields, and in a seamless way, so that multiple users can use the forecast for multiple purposes in a very coherent way. So this follows from the WMO framework, which is called the Global Framework of Climate Services, or GFCS. And so, which is actually focused on these following research and operational applications of with the studies in these following fields like agriculture, food and food security, water, disaster risk reduction, health, and energy. Now, as you can see that agricultural, food security, water, these are two primary focus in this. And India Meteorological Department as well as the Ministry of Earth Sciences, we have adopted this GFCS framework, and we try to improve our research in these fields. So briefly, we addressed this problem. There is a recent release of a very nice climate change scenarios over India, a book actually, and we have seen the current scenarios in which we are living and how it is supposed to be in the near future. So any study on monsoon should give an estimate, should start with this estimate, keeping in mind that how the monsoon variabilities will be changing in future. So in this slide, actually, what I have shown here are different two variables, namely temperature and the rainfall, under different climate change scenarios. So, for example, there are these scenarios are written as RCP 2.6, RCP 4.5, and RCP 8.5, and you can see that in the graph there are multiple lines which indicates the historical run, that is up to 2020, and the future runs, which are actually the model projections based on these RCP scenarios. These both, if you see both the slides, one thing is clear, that you can see that the climate change, the RCP 8.5 scenario, you can say is the most extreme scenario, in which we assume that the carbon dioxide concentration will continue to increase up to 21st century, and then it will stabilize. So in this scenario, you can see there is an RCP 2.6 is actually the best estimate. That means best in which we can say that it has increased up to 2030, and then it has stabilized. So if you see that if we can continue to, if the carbon dioxide concentration or the greenhouse gas concentration increases in the long term, what happens is there is a strong increase in the surface temperature. The left panel is the 2-meter temperature. 2-meter temperature is an estimate of the surface temperature. And the right panel is the precipitation, annual precipitation. That means the rainfall over Indian region. So one thing you can be sure that the projections, although is very much actually confident about the temperature, the rainfall projections are actually not that much confident in future, depending, because these rainfalls are the outproducts of various parameterizations process in the model, and these rainfall estimates are quite uncertain. But one thing is sure, that there is a very strong change going to happen in the near future, in the 50 years. Some more slides will be here. So in such situations, actually, IITM has a Codex South Asia group which looks into these climate model projections are actually global model projections. So there are multiple models and multiple type of data sets used. So, but these models are global models. So the purpose of this Codex group is to provide a very regional scenarios, in which we get a very high resolution data, in which we can say how the global models can be downscaled to the region to generate the regional scenarios. And all this regional scenario analysis actually show the spatial patterns of rainfall and temperature. And one thing is very, and you can see there are, if in this panels, the figures of temperature and the precipitation shows that there are very strong uncertainties in different type of projections. Okay, so these are, and different types of models also. So these uncertainties actually say, but one clear thing is that there is a significant temperature increase over central and the northern parts of India in the near future, say 2030 to 2060 period. And the summer monsoon season precipitation is uncertain not just by magnitude, also in the sign. As I was discussing in the other sign, like the global projection, the regional projections of rainfall are also very uncertain among different models. But the temperature increase is quite certain. And similarly, in the Himalayan region, also there are the studies. The Hindu Kush Himalaya will likely to be warmer, and the Karakoram is also likely to be warmer. And there is a very extreme. There is a very significant observable trend in the extreme weather events in the Hindu Kush Himalaya in the recent past. So if this trend continues, it is consistent with the other global climate model projections in the future scenarios. So IITM actually does a lot of collaborative works in different groups, and these are some of the efforts that are shown here. So in summary, from the climate change, this is a very nice summary of the climate change part, which shows that for how in the if you go to the right, there is an increase in the temperature, and there are some along each row we have plotted different types of aspects that we would like to see what is the impact of climate change. So if you see that there is a for agriculture purpose, if there is a global warming up to 2 to 3 degrees Celsius, then there is a strong impact of food security, because you know better than as agriculture scientists, you know better than me that the crop yields and many other things factors are dependent on the surface temperature, surface moisture, and the surface boundary layer parameters, which is likely to change if there is a warming in the surface temperature. So similarly, there are water impacts in the water ecosystems, extreme weather events, and all these impacts based on our modeling projections. So as the temperature increase, actually the impacts are also feel much more. And that's obvious because model projections are dependent on the temperature increase. The other part, so in this uncertain scenario, we have actually in the IITM and the Ministry of Earth Sciences, we have actually uh, understood the importance of current weather monitoring and the current weather forecasting part. So there are different, so the forecast now is dealt in a very distinct manners, and we have defined different scales of forecast. Okay, so for example, we have defined scales for forecast that we call it as a short range forecast. We have defined another scale of forecast that we call it as the extended range forecast, and we have defined another scale of forecast that is called seasonal forecast. Now, why this definition is there? There are historically there are different perspectives, and most of you who follow rainfall forecast, you know that of this seasonal forecast is the most oldest one, which is practiced in India since last more than 100 years actually. And then there are also very brilliant synoptic meteorologists in the country who has started a synoptic forecast, which we can now call them as the short range forecast. By short range forecast, we mean a forecast up to 1 week maximum. 2 to 3 days to 1 week is the short range of the short range forecast. By extended range forecast, this extended range forecast, which I actually personally work, is actually a forecast that is, you can say, relatively new compared to the short range and the seasonal scale forecast. But its importance is nevertheless very much, as you will see if when I show some applications, because extended range forecast means forecast in 2 to 3 weeks in advance, and most of the agriculture applications, water applications, and other applications, a 2 to 3 week advance forecast gives a well lead time for taking decisions related to various designing of crop parameters and other issues like high rainfall states and low rainfall states, these type of issues. I'll show some example how India IMD is doing in these scales. And the seasonal forecast is of course very important, and it gives a overall idea of how much water will be available for a whole season, or of that is June to September, for example. What would be the net water availability in the or rainfall? So it basically defines the hydrological cycle of seasonal planning and all other things. So those who are working with the long-term projections of agriculture, water management, they are actually more relying on the seasonal forecast. Now, why these scales of different forecasts are needed? Why we cannot run a single forecast? That has a very interesting story, in the sense that it has been understood because of the models, those which we use for forecast, are actually, you cannot generate these projections. For example, in a seasonal forecast, you cannot say for a particular location, say Nasik farmer, how much a Nasik farmer is going to have a water availability on 25th September of this year. So from right starting from now, so there are some limitations as you go seasonal forecast in a small spatial scale. The forecast become more and more inaccurate. So in those cases, we rely on more extended range forecast, which gives not a quantitative idea, but it says that okay, over the subdivisions near Nasik, there is a probability of rainfall coming 2 to 3 weeks. So that is more accurate than the seasonal forecast. And then again, if you want to have a how much rainfall is going to be there over that farmer's place in Nasik, for example, then we have to rely on short range forecasts, which give a quantitative estimates of precipitation over a particular point. So in this way, we actually formulate the water availability, and this is basically the concept of seamless forecast. So we have to run multiple forecast models in multiple scales with multiple accuracy, but overall pictures will emerge depending on the need and depending on the lead time where we need those informations. So in the next few slides, I will actually describe these three scales of forecast, what we are doing, and what actually these data are available, how you can download this data and use it for agriculture applications. So this is what we have discussed, that for example in the top panel, if you take for example, I am taking rainfall from June to September, because June to September is the rainfall month all over India. Now, this in the top panel, what we have plotted is the light fluctuating curve. If you see the light fluctuating curve here, so those curves are the actually daily rainfall values. Okay, and those daily rainfall values are plotted for 3 different years: 1986, 87, and 1988. So what you see, there is lot of day-to-day fluctuations of rainfall over here, and those day-to-day rainfall fluctuations are caused due to weather systems like depressions, like cyclones, and so strong peaks may be associated with depressions or cyclone or small-scale low-pressure system and other things. But if you can smooth this information with some running average, simple running average, and you will find a very nice envelope here developing, and those envelope develops are called the intraseasonal fluctuations. So a few spells of rainfall, if you average it, you will evolve into a very nice smooth curve. So that smooth curve actually is called the intraseasonal variability. So there is a synoptic variability, which we say as a day-to-day variability, and then above with we can derive an envelope of variability, which we can call it as the intraseasonal variability. So this is, and you can see for different years, actually this is actually different. So for example, 1988 was a very strong monsoon year. You see that there is the seasonal mean is denoted by this line. So it is very above a very strong seasonal mean. It is clamped, and there is a strong variability of the synoptic scale. Similarly, 87 is a drought year, and you will see such type of events happening. So every year you will find something called a synoptic scale variability every season, and an intraseasonal variability. So basically, in terms of forecasting, the synoptic scale variability can be forecasted more in the short range, because you are trying to forecast day-to-day rainfall fluctuations. The intraseasonal variability, as you can see, those are much smooth curve, and we have some hope of forecasting those variability in the longer lead term. In the bottom panel, actually, in the left, you see that is the called the seasonal variability of monsoon. The blue curve shows that this seasonal variability, if you consider, there will be some years which you have very strong positive peaks, and there will be some years which you have strong negative peaks. And this seasonal, as I said, this is the aim of seasonal forecast, to say one season in advance what is likely rainfall for the June to September season during for the next season. And for that purpose, mostly 100 years back, right from the time of Walker and Blandford, they had the renowned meteorologist here, who has worked in India Meteorological Department in Pune. So they have actually derived something called the teleconnections. So what they have shown is that there are certain fluctuations of sea surface temperature in the Pacific, which can actually give a good correlation of with rainfall over Indian region. Now these teleconnections are like, even if it is called a teleconnection, because it is so called a far field effect, that means it is happening over the Pacific and we are trying to focus over the Indian region. It is quite robust nonetheless, in the sense that you can see the blue lines, which has strong rainfall anomaly, are likely associated with a La Nina type of situation, and the red bars actually shows a El Nino type of situation. So El Nino and La Nina are the warm and the cold phase of sea surface temperature in the equatorial Pacific. So based on these, actually, lot of studies has been done in past 100 years, and the basic perspective of the seasonal forecast is that these El Nino and La Nina impacts the monsoon, and if you can get a forecast of El Nino La Nina, then you are likely to get a forecast of monsoon, at least the extreme monsoon years. Now, in the recent times, actually, this has been contested by a lot of new studies, and lot of other effects has been seen, like the snow covers over the Eurasia, and many other features are there. So, based on all these things, people have formulated a lot of statistical models which gives forecast of monsoon. And similarly, if right now, which we are using are a set of dynamical models in which we solve certain numerical equations, and those numerical equations are used to forecast the monsoon one season in advance. I'll come more details on this thing. The right side is a very interesting graph which shows that how the long past 100 years rainfall has varied over Indian region. You will see that there is a red smooth curve in which in particular decades, 30 years, you have a low phase. In some particular year you have a high phase. Again, in the recent time there is a low phase. So like this type of situation prevails. So this is called the decadal or multi-decadal variability of monsoon. And above this variability, you have to superimpose the climate change effects. So So it is a very complex problem how come climate change is impacting the monsoon, and you have to it is very difficult to separate whether it is a part of the multi-decadal variability or whether it is related to the climate change effect. And this, as you see, this rainfall variability should impact the rainfall, impact the agricultural production over the Indian region. During certain time we are supposed to have less rainfall, and during certain time we are supposed to have more rainfall. So agriculture and the water availability has to be very planned differently in these different decades. So we, and also we have seen one study that it shows that I will go back to one slide back. In this slide, here I am saying that the synoptic variability, like this positive phases, we call normally it as the active phases, and the phases which is below the climatology phase, we call normally this type of situations as break phases. That means break from the strong rainfall, and active means strong active convective rainfall happening over Indian region. So model projections actually show that strong during strong monsoon years, active spell will be more intense, more wet. So it means that when it will rain more, and when it will not rain, it will be strong. It will not rain for a long time. So, but we know that monsoon has been stable for a long time. So net seasonal quantum of rainfall does not change much. What it implies is that there is a lot of studies also have seen that extreme events will be much more frequent, and so prediction of extreme events has to be done, or for management purpose, or we have to have a scenario type of prediction in which we have to generate under what conditions there will be more extreme events, and under what conditions there will be less extreme events, and this will impact our management of water and agriculture is over Indian subcontinent. So what we see here is this is the same thing. So the seasonal forecast, if we start with the seasonal forecast, so seasonal forecast has importance in selection of crops, cultivable area, management of water resources. So based on season, if some year is predicted to be deficit, then states are sensitized to prepare for contingency plan through identification of alternate variety of crops and other inputs. And similarly, if we have the extended range forecast 2 to 3 weeks, based on this forecast, some tactical decisions can be taken, same as the selection of crops over a small block, for example, in this particular state. Choosing the windows of showing and harvesting, irrigation scheduling, optimal water use, mitigation from adverse weather events, nutrient management like fertilizer applications, and when one should apply the fertilizer, that there will not be much heavy, or the pesticide applications in which one should not apply pesticides when there is a strong chances of rainfall in the next week. So like this type of decision taking exercises can be done with the rainfall of extended range agriculture. The short range and the medium range means up to 1 or 2 weeks. So short range means up to 5 days. So these are like activities in which land preparation, collection of plant material, planting or seeding, showing management of crops, application of fertilizer, thinning, weeding, pest and disease control, management of grazing system. So all these decisions can be taken, and we have over a small region. For example, we can try to use the short range forecast for a small village or a small block over Indian region. So the short range based on the inputs of the seasonal and the extended range, the short range forecast give the quantitative decision taking process, helps in the quantitative decision taking process in the day-to-day use. Now, how we do seasonal forecast? Let us give some example. So this plot I am repeating. So basically, seasonal forecast means we have to actually give forecast of that whether in the next season the rainfall would be normal, above normal, or below normal type of situations. So this is what we are trying to forecast in the seasonal forecast. And Ministry of Earth Sciences actually gives seasonal forecast. As I said, that the seasonal forecast is strongly linked to the forecast of the El Nino or the La Nino type of situations. The Ministry of Earth Sciences generate monthly forecast of El Nino southern oscillations and other teleconnections like Indian Ocean Dipole, which are actually useful for providing the rainfall over in Indian region. So, but we have in the IITM we run the CFS model, that is a dynamical model using the using we solved some of the equations, five sets of equations, and solving those equations we generate the sea surface temperature forecast, rainfall forecast, and all other forecast. So in this way we have in numerical forecast there is a condition called initial condition. So from one initial condition forecast, we try to forecast in the next few month forecast. So this is a bulletin. I have just given a snapshot of this bulletin from Ministry of Earth Sciences, and this bulletin can be downloaded, and you can see how the sea surface temperature forecast, how the precipitation forecast for different seasons like October, November. This is an example of forecast. The plot shows here in this case that we have from the September 2016 initial condition, we are forecasting the sea surface temperature anomaly over October, November, December, average November, December, January, and so on. So like this, we are trying to forecast in the long lead time how there will be the sea surface. And we always look for signals in the Pacific region, for example, where if we have a strong signals in the Pacific region, we'll say there is a El Nino developing or La Nina developing, based on which the rainfall forecast also can be made. So WMO, so as a part of WMO, there is a forum called SASCOF Forum, and Seasonal Climate Outlook for South Asia, where all the small countries over the Indian subcontinents and many other regions are covered. Detailed day-to-day forecast are given. We give forecast of rainfall anomaly over different region, over different region and different times, and we different months also, aggregating over forecast over different months. So for example, here is the interpretation of seasonal forecast at district level. So this is an example slide taken from SASCOF 6. For example, we have picked a subdivision over Rajasthan state, which shows that so there are a set of models, those are run, and based on the set of models which we have run, we call multi-ensemble forecast. We give a probabilistic information, because if you remember, I have that over a very small subdivision scale, seasonal forecast may not be very accurate. So probabilistic forecast are given. So for example, in this case, 45% chance of below normal rainfall over the season for different subdivisions here or blocks here over Rajasthan. It shows that there has to be so district authorities can take decisions based on this type of forecast. In the short medium range forecast, we actually run in IITM. We have a prediction system called GEFS, and from the initial conditions we get, we run this forecast for different applications like tropical storms, if there is a strong storm is present, and so that the extreme type of rainfall events are there. and based on a set of operations, actually the output is given, and the output is 240 hours forecast output at a very high resolution, 0.125. So it is 10 to 12 kilometer forecast. Up to 10 days these forecasts are given, and we similarly generate a 21 member ensemble, and from this ensemble run we can give a probabilistic output of the probabilistic output from the forecast, and the ensemble mean and the standard deviation. All these informations are given so that we give a short range forecast over in a. So this is an example of 72-hour lead time forecast from certain initial conditions. This is 7 June, and the forecast is valid for 10 June. So we start our model forecast from the left side here, and from this level, actually what we have actually seen is that forecasts are different ensembles, so slightly different values of rainfall. For example, if you see, some ensembles show there is a strong rainfall over here, some ensemble does not show a strong ensemble. The observed rainfall is plotted here in the bottom right. So, and we can generate, what we generate is a probabilistic type of information from this type of runs. So for example, here what we have shown is like what is the probability of rainfall greater than 6 centimeter per day over different small blocks of Indian region. And you see that there are certain subdivisions of blocks which shows that there is a strong probability of rainfall over 60 millimeter per day, and certain says there is no. So based on this probability, so 60, say 6 centimeter or 60 millimeter per day, you can take it as a very strong rainfall event, based on which you can actually give the output to the local stakeholders who can actually use this forecast, for example, to run the crop model or other things to decide the cropping pattern of this or the applications of water irrigation process. All other applications can be formulated 3 days in advance using this type of forecast. So here is another forecast for different blocks we have shown, and it shows that what is the chances of rain for different threshold categories, which is shown here: 2.5, 15, 115, 195, like this. So these are the different type of forecast which we can generate, and based on color coding you can say which block is having what type of rainfall of different region, like that. So this is the same thing, but this is, we have generated a dynamic map. I hope it is visible in the animation is visible, and it shows that this is the how it is going to be a 240 up to forecast from certain initial condition. 18 February 2000. 15th February 2019 is the initial condition, and the forecast is run for 10 days or 240 hours, and this is shown here. So here is the actual rainfall. What is the exceedance of rainfall? This is the rainfall per day, and in the right, in this case, you see that the probability is shown here. So rainfall probability greater than 2.5 millimeter per day, rainfall probability greater than 15.6 millimeter per day. So rainfall probability greater than 65.5 millimeter. So based on this threshold criteria, we can actually generate information that, for example, in this particular focus shows that there are strong probabilities of rainfall greater than 25.5, but their chances thins below 15 millimeter per day. So mostly we can expect that our high rainfall probability is much low over the most of the parts of the Indian region. So based on this estimate, we can safely say the mostly the rainfall is likely to be above 2.5 centimeter or but less than 15.6 millimeter per day for this particular focus. So based on this, we get a range of rainfall, and from this range of rainfall estimate, we actually get forecast estimate. and this information can be used for other purpose. So this is another forecast example which we have shown for example, wind forecast, wind speed forecast, solar irradiance forecast. So wind speed forecast is useful, for example, for those who farm, who generate wind energy, and the solar irradiance forecast is used also for the how much, because of the cloud free sky and the cloudy sky, those type of will give the solar irradiance, and those will help to generate the non-conventional sources of energies like wind energy and the solar energy. So like this, there are a lot of applications of this forecast over different regions. So we give a forecast of cyclogenesis, how is the cyclone in the last season. We have two cyclones, so we know that this type of forecasts are very useful. And we have a forecast of heavy rainfall. Similarly, some people are trying to use this forecast for fog forecast and hydrological modeling, and this of course block level and district level agriculture applications is the most important in terms of providing the input to the agricultural community, which is the most widespread applications all over India right now. In the extended range forecast, actually, as I said, this forecast is for the forecast is based on same model, but we have to use we are forecasting not the day-to-day fluctuations. We are forecasting a slow evolution of the monsoon rainfall system over Indian region. So it may not give you exactly very high range of precipitation, because it is the average of 1 week forecast or 5-day forecast, but it will give you an idea on how the next week rainfall is likely to be, or after next 2 weeks forecast is likely to be. Maybe we do not need what is the rainfall on a particular day after 2 weeks. It is for application we need that what would be the weekly average rainfall from today after 2 weeks. So that forecast would be useful for many purposes, including agricultural applications. So here we have developed in IITM, our group has developed this extended range focus system from 2011. We have started working, and right now we have applied this forecast on many systems, including the agriculture applications and other things. And we have used, for example, onset prediction. Onset prediction is a very important prediction, so that gives a starting time of the rainfall over Indian region, and this forecast is given 10 to 15 days in advance, so there is a likely chance of onset in after next 2 weeks. So that gives a very important information. So our forecast we have actually compared with different global model forecast, and so what we are trying to say here is ECMF is a another model which is one of the best model in the world, which gives the rainfall forecast. And initially when we have started our modeling, we start the models with different resolutions, different type of initializations, and so here we have shown model forecast for two particular resolutions, C126 and C382. So these are you can just assume that these are two versions of the same model, but it is run at different forecast outputs are generated at different resolutions. So we see that the ECMWF forecast and the forecasts are now averaged over pentad. So by pentad, we mean it is a 5-day lead time average forecast. So what we are trying to say here is that our forecast of individual models were very less skill compared this. The y-axis is the ordinate is the correlation after for the first 5-day average starting from today, and then the second 6 to 10 day, then 11 to 15 day, like that. This is the forecast skill is shown, and it is shown that our model was much less than the ECMWF in longer lead time. So we tried to improve it, and based on different applications, we finally able to get a forecast skill very high comparable to this red curve ECMWF so there is a technique called bias correction using which we have actually improved this forecast. Uh, so in the extended range, the idea is we cannot get a very good forecast if we use a single model, but rather we have to use a combination of models which are very slightly different physical processes are differing in the models, and then we can get actually an improved forecast in the extended range. So currently, actually, our forecast, if you see in the longer lead time, has the similar skill as that of the ECMWF forecast, uh, especially in the Pentile 3, which means that it is 11 to 15 day forecast. Pentile 4 is actually, we have slightly better in the Pentile 4, so 16 to 20 day forecast. And so we get a skill comparable to the ECMWF by combining a set of different versions of the model. So we actually have generated the multimodal ensemble forecast based on this run, and these forecasts are actually available from and we have compared the ECMWF forecast with the IITM forecast, and these shadings are the correlation coefficients. Blue is the more blue, it is the high correlation, and you see that the for subdivision wise scale also our focus compare well up to three focus up to 3 pentad or 11 to 15, and all both the model focus skill means deteriorate beyond 15 days or fourth in the 15 to 20, but at least some subdivisions can have a better skill in beyond 15 days in both the models. So based on this forecast application, we can say that the 11 to 15 day is a very optimal lead time in which the extended range forecast can be actually given, and it would help to generate the subdivision wise this subdivision, I mean, this is the IMD subdivision, like which we have generated to generate small scale forecast, and these subdivisions wise rainfall forecast can be given as an estimate. It consists of a few number of blocks, so it can be used for verifications of forecast in small blocks and small villages, because datas are available at least in the subdivision scale in the model. So we prefer to give the forecast in the subdivision scale. Now, few applications I want to show in the final part. So, like as I said, that the over the this so as extended range forecast has been separated in given in different smaller regions of India. So, as I said, seasonal forecast can be accurate over all India scale. The extended range forecast can be accurate over smaller scale. So, those are the regions after a lot of experimentations and some scientific basis, these regions are chosen. And we can see that there are actually, these regions are actually given. So, central India, northeast India, northwest India, south peninsular India, and the monsoon zone. This box is the monsoon zone. So this is the box where we can actually have a good forecast skill over Indian region. And this is actually shown for the year 2016. And here is, I'll give a brief descriptions of this forecast. The top panel shows the percentage departure from the normal or climatological phase, and the pink one is the observation curve, and these bars are the forecast bars. So it is forecasted at pentad 1 lead time. P1 means pentad 1. That means if we start forecast from today, this is the forecast from tomorrow to next 5-day average. So this is the pentad 1 lead time. Similarly, pentad 2, pentad 3, and pentad 4. So the top panel shows the average of multiple model ensemble average forecast of multiple models, which shows that there is the envelope can be predicted, 5-day average envelope As I said that I am talking of envelope. This is not the day-to-day rainfall because this is 5 day average forecast. So this pentad forecast is the encompasses the day-to-day variability. So it is a actually average of every 5-day forecast. So similarly, pentad 1 forecast, pentad 2 forecast, pentad 3 forecast, and pentad 4 forecast. Now, occasionally, what happens is that the deterministic forecasts are not accurate. In such a situations, what is needed is a probabilistic forecast. In this probabilistic forecast, what we give, these are the three small panels in which we say that what is the probability of the percentage of the models that gives forecast in three categories. So three category probabilistic forecast we give. One is the below normal category, one is the less than 40% is the below normal, above 40% is the above 40% of the normal is the above normal for and the near normal is the plus minus 40%. So if you see here that the first week for starting from June 1 to June 25th, there is a strong probability of a negative rainfall forecast. So what it says is that in the probabilistic sense, we can sometimes in the long lead time there are many times when the probabilistic forecasts are useful, we can get more confidence in the model. Uh, and these are the skills, the pattern correlation skills over different regions. So as you see that the monsoon zone, the forecast is very skillful up to 11 to 15 days. So we can, so zero point 0.5 correlation or above is we are calling it as the skillful. And similarly, in different regions, there are forecasts. For example, the forecast over the Northeast India is a real challenge in the fourth pentad, and there could be very less skills, and still we are working on in improving the skills over these regions. So these are the research type of problems in the extended range applications. And similarly, like pentad, we have also IMD prefer to use the weekly forecast. So we have generated the weekly forecast. So instead of pentad, this is the 5-day or week 1 average, week 2 average, week 3 average, and week 4 average. And we have plotted the same thing for a different year, 2017. And this is the skill for different week for different regions. And as you usually you can see, the Northeast India has less skill, but the other regions so fairly good skills, so that we can use this forecast at least up to 2 to 3 weeks lead time. So 2018, similarly, we have the forecast over, this is the area average forecast, and this is the forecast for each of the meteorological subdivisions over India, and the same informations can be derived based on this forecast. Uh, other applications are this onset, as I was saying, the onset progression and withdrawal are very important forecast in this case. So what we are trying to see is this onset type situation. So this is forecast is starting from 16th May initial conditions, and the onset occurred around the 2nd or 3rd June. So this is the onset day, and we tried to focus it. And if you see the animation closely, the IMD onset criteria was we can actually verify. So what we got from this forecast in the long lead, so there is a low pressure system that may form over Bay of Bengal around this and move northward. So this would make its onset over. This would activate the monsoon system, and then it is likely that the onset over Kerala would happen over the around 4th June onwards. So, and the other important information we got is after onset, the progression of the monsoon might be slackened till 15 June due to the presence of a low-level anticyclonic circulation over central India. So what happens is when we give this type of forecast from 16th May initial conditions, so it says that there will be a low pressure, but the low pressure is not going to rejuvenate the monsoon all over the Indian, because there is a development of another anticyclone, low-level anticyclone over Indian region, and that would actually kill their advancement. So this type of quantitative informations can be given from this type of extended range forecast. And this is also same thing, but another way, the delayed progression, what we have seen that the monsoon. Okay, what happens in sometimes the monsoon is there is a monsoon onset, but the progression is very weak. So people wait for the progression, but the progression does not happen very seriously, and then we can actually. So such type of scenarios are actually projected in the extended range forecast. Similarly, onset withdrawal, we can see this onset and withdrawal forecast. So the top here is the observation, and the bottom two are the two actually models, which we're saying that we are using a set of models. These we have just separated the result from the set of model, just to say that why we have separated, because you see the two models occasionally give a little different information. So a combination of the model forecast is always a very important issue in generating the forecast. Similarly, we give the monthly extreme forecast, for example, how the monthly extremes are likely to be in different categories. And it is shown here that for a particular year, the monthly extremes forecast can be forecasted in different lead times also. So this is also another 2014 example of a low June forecast in different lead times. So up to 20 day in advance, we can see there is a probability of low rainfall forecast. So red, you can see the red panels showing here. Uh, uh, so the extra the other type of forecast are the extremes, heat waves, cold waves, and the cyclones, of course. So these are the some of the. This is a forecast of Uttarakhand extreme event. So we have to remember that we are not actually trying to focus the extreme event here. What we are trying to say is that we are saying that there will be certain conditions that will be favorable for having a extreme event type of situation, and that situation can be actually predicted long time. But of course, we will not say that from 20 days in advance we are saying that there will be an extreme event, but it shows that there will be a situation which provides a condition that would lead to very strong rainfall events. Now, next, using this forecast, we can use a short range forecast, high resolution forecast, which will give you the impact of actual quantitative precipitation over Indian region. And this is a heat wave forecast. So there are, we again categorize as the three type of category with conditions: the hot heat wave and the severe heat wave. So depending on the temperature criteria, and so these criteria we have published in paper, so we can actually share this thing. So this shows actually that in this particular forecast we can get. So this is May 2018 forecast. So there you can see there model shows there are severe heat wave forecast over certain region, but hot regions will be prevailing over most of the parts of the India, over different region. This is the observation. Okay, and these are the forecasts in the different categories. So this is the closest forecast. These are the forecast from farthest initial conditions. So even from very far initial conditions, also we can have a forecast of hot like conditions or heat wave like conditions. Based on this forecast, we can actually plan medical emergencies, or it can be used to generate the agricultural input for in terms of how much temperature and water vapor we need for the model. So there is a cold wave focus during this same time, and I'll not. So this cold wave forecast means we have to give a forecast over the minimum temperature. These are the this is the average of the 5-day forecast, and this is the observation, and these are the forecast in different lead time, and this is given here. So we can see that the cold wave forecast also can be given based on this. And this cold wave forecast are important forecast for different other parts of the region where we can have electricity generation, and many other issues depend on the uses of electricity depend on this type of forecast. So this is another forecast. I'm skipping this. So the other important forecast, especially for the agricultural purpose, is the transition forecast, which is the transition from active to break and the break to active. So situations like this is very important. Like we have to need to predict when there is a transition from A to B, strong to positive to negative, and from negative to somewhat positive state. So such type of transitions are very important because this is a very low frequency type of transitions, and such transitions would be important for agriculture purposes because we can see that how the long term rainfall will be there, or the long term absence of rainfall will be there. So this is the forecast, and we have shown here in terms of subdivision. This is actually prepared by IMD, Dr. D.R. Patnaik. So we got this forecast from them, and although the model is the same model that which we are doing, actually the same model, but it is prepared in a way and is forecast in a different region. Yeah, actually, I am seeing some of the questions, but I am not sure how to answer right now. So let me finish it, then I'll actually uh, give the some of the answers. So there is a long dry spell forecast. For example, how is the dry spell? How long the dry spell is going to persist? Persist in the future. Those type of forecast can be given in this way, and these are the some case studies which we have given. So, for example, it is 28 July to 3rd August, then 4th to 10th. So you can see the in observation there will be long dry spells prevailing for the whole period, and the forecast also actually shows that the same forecast is available for, and it is showing the persistence of the dry spell. So such type of dry spell persistence can be forecasted in this region. So for this is the week to active. So when in the next week, whether it is going to be active, mostly this type of informations can be given, and this is another example of how we can forecast it. So there is a active phase developed in the 25th to 31st August, and this is same forecast from larger lead times, which actually shows that most of the subdivisions is going to get a high rainfall over this region. Of course, there are many subdivisions where the forecasts are not correct. As you may remember that some of the subdivisions in the northeast and hilly region, the 3 to 4 week forecast cannot be given in a very efficient manner. So this is also I have discussed. So agromet advisory bulletins actually are prepared. So this is an example of this agromet advisory bulletins based on extended. I am sure so many of you have seen this type of advisories. So they give the rainfall estimates for different periods, say 12th October to 18th October, then 19th October to 25th. So 2 weeks forecast are given here based on the rainfall ability, and similarly another is there for the next 2 weeks how it is going to be. And based on this advisories, these are the advisories given by the agromet people. So how for different subdivisions of Marathwada, Vidarbha, how this can be done, and these are the advisories from the agriculture purposes. So based on this extended range forecast, we are actually going to get such type of advisories and informations in this way. So this is the same continuation, and so these people have so this is another case study actually. So when people have followed the advisory, and when so I think many of you are aware of these slides. So there was a wide publicity of this advisory for showing so even advisory given, like even though there was sufficient realized rainfall during the first 10 days of June, fulfilling the criteria of sowing, farmers were advised to wait sufficient rainfall to undertake sowing. So those who followed the advisory, because there was a wide publicity, so there was a forecast was correct and sowing was not undertaken. There was no report of or less crop loss. So finally, this extended range forecast has applications in agriculture, health, energy sector, urban rural planning, and extreme event predictions, dam, water management, and insurance, reinsurance business. And agromet advisories are given from IND in these bulletins, and the hydrological and land surface product advisories are also given from the IIT Gandhinagar and IMD. So this can be looked for different purposes, and we have a lot of scope in this scale of focus, especially based on the demands from the stakeholders and based on the collaborations with the agricultural scientists and many other places. We have so demand for block level or taluka level forecast for seasonal scale is not feasible. So we have to the extended range forecast can be actually given in these different scales, and we have to improve various aspects of the forecast. And based on this improvement, we are going to, of course, we are going to develop new algorithms for predictions. So this is a website that we can follow. Of course, IMD is the official forecaster for this purpose, but for any research purpose and research use, you can use this type of forecast. And if you have some queries, you can come back to our group, and we can actually have we can plan some for research purpose. We can plan different collaborative work, and it based on your feedback, we can tune our forecast depending on the need. So I'll stop here. Thank you for your attention.
Sir, before ending the session, shall we take some of the questions which we have
Yes,
received from
yes,
the
please.
participants?
Yes, please.
Snail,
Yes, sir.
I'll request you to take up the questions from the chat box.
Okay,
Many
sir.
participants have placed their questions. I think you can take up some of the selective questions, some important questions from the chat box,
Okay, sir.
so that our expert can answer the questions.
Okay, sir. Rajiv, sir, shall we start our question answer session?
Yes, please.
Okay. First question is from Wahid Hussain. What is the El Nino and La Nina effect on Indian monsoon?
Okay, so El Nino and La Nina is a very important phenomena in the tropical Pacific. So what happens is that due to lot of reasons which I am not going to explain, the phenomena is like the sea surface temperature normally gets much warmer than the normal what it is supposed to be, and this phenomena is called the El Nino. And the reverse is due to some dynamical process. The sea surface temperature gets cooler. It is called the La Nina. Now, what happens is, the global if atmospheric general circulation, based on which monsoon is a part of it, this general circulation is affected very strongly due to the El Nino process. And what happens is that there is a cell called the Walker cell. The Walker cell actually is shifted to a different positions compared to the normal position, which is in the normal years. So what happens is there is a strong suppression of convection when there is a El Nino over the Pacific. And since this is a Pacific is a remote place compared to the Indian region, so there is a long spatial distance, but it is connected by this atmospheric response of suppressed convection. We call it as a teleconnection process, during which this rainfall suppression takes place if there is a warming over the Pacific, and rainfall increased in the rainfall takes place if there is a cooling over the Pacific region. And that would help us to determine how the monsoon behaves over Indian region. So it is an important predictor for monsoon, and it is known for a long period.
Okay, thank you, sir. Next question is from Kathir Velan. What is the implications of Cordex on climate change?
See, Cordex is just a project in which we are actually doing the downscaling of the climate data. So what happens is, the climate projections are always based on large scale global models. Those global models have lot of errors in different phases, different times. And so, for example, if you want to understand what would be the climate change over the state of Maharashtra, for example, the global model projections has to be fine-tuned because the models are run as a part of a global system and global. So regional models and regional downscaling. We use this term called downscaling. That means that you are scaling your forecast to a very small regional level depending on your need. For example, any Mediterranean country, small islands like Maldives and all other places, you cannot rely really directly on the large scale dynamics. So you have to devise a method where you get focused on the regional basis. So projects like Codex are actually using this type of downscale high resolution regional focused over Indian region. So you can go ahead in the IITM website, and you can download the Codex data, and you can get various regional information from the Codex page actually. Thank you.
Okay, thank you, sir. Next question is from Modula Mahadevi. What are the best softwares for analyzing the agromet data for India?
Well, I will not be very, I think I am not the relevant person to answer this question. Mostly, Agromet advisor is you can, what we give, the products are based on simple meteorological softwares, and products are made of meteorological softwares, and the datas are given in terms of NetCDF format and the GRIP format. These are international standard format. You can use several softwares to read the data and use it for agromet applications. Of course, we also give data in the ASCII format also, but for a big this is the problem of big data. It's a very important question because big data is now you all hear this term big data. So meteorological data can be safely considered as a big data type of problem where you need a efficient software system. So for example, right now we use Python type of softwares based on Python, and of course GIS is always very efficient way of doing it. If you have a license, you can use, but otherwise Python is a nice open source software which you can use actually.
Okay, thank you, sir. Next question is from Anush Graham. Sir, can we forecast from SPSS ARIMA model? Is it still reliable or not?
Well, see, ARIMA models and all other simple models are based on simple assumptions. Okay, so these type of simple assumptions are good in certain restricted situations. The need to go for a global model, climate model, is this because climate and the rainfall system are a very multidimensional system which you have lot of players in it, lot of factors in it, And above all, this is after few days the situation goes chaotic. Okay, so the thing is, under certain restrictive criteria, such type of models can be good, but you there is that it is sure that there could not be a general model for every purpose. So you can devise a model, simple model for the simple purpose, but there is a very likely chance that there will be a failure in this model if you do not incorporate all the important physical factors. Those are considered in the model. So better to use a global model like this, and then use this data to generate your own forecast based on some statistical post processing, and then you can use this data for your purpose. Okay.
Okay. Next question is from Dr. Navneet Kaur. What is exact definition of dry and wet spells? Criteria for dry spell estimation, and will their estimation be region specific as for rainfed and irrigated?
Yeah, that's a very important question. So mostly, if you see my PPT, so the dry spell and the wet spell, what we have defined is actually based on a criteria called the monsoon zone. Okay, so there is a slide which I have. I think it can be shared to all participants, where we have defined a region called the monsoon zone. Okay, so this dry and wet spell that I have defined here, or in this plot you have seen the rainfall, it is based on that core monsoon zone of in India, which I have defined as MZI in several plots. So in the MZI, we normally define as the active and break spells. That is a standard definition. But for your purpose, if you have to define it, you have to use a long-term statistical data, and then from this you can define the active and break spells for that region. But of course it may not coincide with what is there is a standard defined in this case by IMD, or the research purpose what we define. So there is a very nice research paper which we give we, if you Google active and break spells of monsoon, you will get the Dr. Rajivan. There is a paper by him and many other co-authors. So which actually defined dry and active and break spells in this case. And we take this standard, but we also assume that it is defined over a monsoon zone region. So if you want to use a similar concept for a smaller region, of course you can use it, but you have to define a different statistics, and this may not be, the results may not be same as what we have discussed here. Okay.
Thank you, sir. Next question is from Dr. Ashok Kumar. How to forecast drought situation?
Well, the drought meteorology, in meteorology the drought situation, we will not say drought, because drought is a agricultural drought, that can be meteorological drought. So what we basically focused here is the active spell or deficient rainfall spell. So if you want to define a seasonal scale forecast, for example, we can take that it is a deficient rainfall. I'm avoiding the term drought, because drought is it has a lot of implications. It's not so deficient rainfall. Normally we can take, if it is rainfall is below 95% of the seasonal mean, we can call it a seasonal mean, means June to September average. If the rainfall is less than 95% of the seasonal mean all over India, then it can be called as a deficient rainfall phase, which can be, of course, used in terms of loose definition of droughts actually for agricultural purpose.
Thank you, sir. Next question is from Sandeep Kumar. IMD has been validated for extended range forecast. Is it very useful for agricultural operation as well as planning?
Yeah, actually, see, agricultural planning, just I have shown here, because the time scale of 2 to 3 weeks is a very good time scale. It is a use for planning for several purposes. So we can give examples of different situations in which 2 to 3 weeks forecast is very important for hydrology, agricultural applications in different scales. So IMD has operationalized this extended range forecast, and if you go to IMD website, you will every week you will get one extended range forecast. Every Wednesday, you will get the extended range forecast, and based on that, the weekly planning can be done. And I believe for agriculture purpose, it is very useful because a weekly planning of agriculture purpose gives a sufficient lead time for normal planning of deciding the dates of sowing and other things.
Okay, thank you, sir. Next question is from Dr. Debashish Jina. Sir, why not extended range and long range forecasting is not feasible till nowadays? Is it possible in future so that the agrarian sector will be benefited from that mainly in Kharif season?
Well, nowadays, I think last 3 4 years we are actually having the extended range and the long range forecast. By long range, you mean seasonal forecast, and I guess seasonal forecast is almost 100 years old. So, but the thing is, there are different way of applications. I mean, you cannot apply as very accurately, you cannot quantitatively decide the long range forecast over a particular village, for example. For that purpose, the short range forecast of 2 to 3 days is very useful. But if you want to decide that whether a particular state or particular region will receive a big region will receive a good rainfall, bad rainfall, normal rainfall, for those type of situations, long range forecast are possible. Extended range forecast, of course, is a relatively new because of, as you have seen in my presentation, I have skipped the modeling part. The modeling of the extended range forecast requires very strong computational part, and all other issues are involved. And so slowly we have come up with a model of consistent model of extended range forecast. And if you go to a global scale, there is a, if you Google S2S forecast, you will find a lot of models are now doing this seasonal to sub-seasonal forecast, which is the other name of long range and extended range forecast. And there are nowadays it is possible, you can get data, you can verify it, you can use the past data for your agricultural application softwares, and you can generate the agricultural scenarios also using, nowadays is possible.
Okay, thank you, sir. Next question is from Shivlila S. Kukanur. How many years observations to be taken to create a effective model?
Well, that depends on the scale which you are talking. For example, if you want to generate a seasonal forecast, maybe at least 50 years to 100 years observation is required. So that means 50 to 100 seasons data at least we need to construct a statistical model. For dynamical model, actually, we generally prefer 15 years of hindcast in terms of operational sense. So hindcast means past forecast cases. So there, if there are 15 years of past forecast data, then we say that we have some sufficient sample of evaluating a dynamical forecast. And for extended range forecast also, 15 to 20 years data is generated for evaluation of forecast. And I think these two, for a dynamical model, you can generate. For statistical model, of course, nowadays lot of data is available, and you can as much as data as you get, you will actually get the statistical forecast. So the more the better, but 15 to 20 years now for dynamical forecast is a good data set, that I will say.
Thank you, sir. Next question is from Nikhil Shrishel. Is there any model available in India for predicting climate change scenario under RCP, and which RCP band is suitable for India?
Well, the art system model, there, if you go to IITM website, there is a center called Center for Climate Change Research, CCCR. So we in IITM we have a art system model, and this is participating in the CMIP evaluations, and the data I think it will be available soon. But there is a recent chapter book come out from Springer, which actually discuss all these issues based on these observations. So the art system model developed in IITM actually that is useful. And the RCP scenario, see, this is a scientifically, I mean, it is very difficult to tell because it depends on RCP scenarios are generated based on which you think that it would be feasible. For example, if we are trying to take proactive steps and stop all the carbon dioxide emissions, greenhouse gas emissions situations, then maybe RCP 2.5 or 6 is sufficient. But if we do not stop anything and we continue to raise the carbon dioxide at the current level, then 8.5 is the extreme scenario. So normally people use multiple scenarios to say that what is the range of scenarios you get. Okay, so I don't know. I mean, it is not a part of a scientific community to decide which RCP, but we need to have estimates of all the RCP scenarios. If at least the extreme case we have to best and the worst scenario we need to get actually.
Okay. Thank you, sir. Sir, Andre, sir.
Yes, Snehal, I think one more question we should take up from Dr. Ravi Patil.
Uh, okay.
Uh, he wants his question is regarding the relation between the El Nino and La Nina with the southwest monsoon in India. What is the exact relation proven by the studies? Some of the scientists say there is no relation, some say weak relation, and some say there is a strong relation. What is the actual correct situation?
Well, I will show you a graph here. So So here is a plot I am keeping in the screen. The plot says that these are the bar shows the rainfall from January 1860 to most recent. You can extend it much more recent. So the colors in these bars represent the sea surface temperatures, okay, over the Pacific. So if you see most of the y-axis ordinate is actually the summer monsoon rainfall depending millimeter departure from the normal. So zero means the climatology, whatever is the climatology we take 850 or something like that. So and it is the departure from the climatology. So this is based on purely based on observation. So what it shows here is that in the past most of the serious departure in the negative side is associated with the red type of coloring. Okay, that means there is a warm sea surface temperature over the Pacific, and whenever there is a positive departure, those are the blue shades, that is the SST over the Pacific is cooler. So based on this relationship, based on this observation, you can easily say that out of all these scenarios, most of the events of extreme rainfall, extreme seasonal mean rainfall, are associated with either El Nino or La Nina. So there is no denying fact that the El Nino or La Nina until recent time gives the best test. So the correlation with rainfall with El Nino and sea surface temperature is still 0.55 to 0.56. So it explains about a lot of variability, 25% of the variability of the Indian monsoon rainfall. Now, whether this is true in all times? No, this is not true in all times. You will find some of the departures in the graph where it is shown that some situations may arise that there are other factors like IOD. For example, the extratropical teleconnections, for example, can come and that will neutralize that. But to a first order, El Nino and La Nina still continues to be effective. Now there are debates in the community whether warming in which part of the Pacific is more important. I am not going into the debate, but it is a part of the system that El Nino and La Nina still contributes to the monsoon variability. At least in the past 150 years, data show that.
Thank you, sir. Snell,
Yes,
are there any more questions, or shall we end the session, today's session?
we can end the session, sir. No more questions.
Okay, thank you. So if you need
Uh,
the slides, I can share the slides with Snail or any.
Yes, sir, please, if
Okay.
you can. And one more thing, your lecture note, if it is not sent, please kindly send it. So we are thinking to bring out a compendium of all the lectures.
Okay.
Previous batch training also, we have uh, prepared the compendium, and maybe during the valedictory function of this training program,
Okay.
we'll be publishing that.
Okay.
Similarly, we'll publish this trainings compendium in the next training or some other event in the future.
Okay.
I would also request one more thing, one announcement for participants just before the ending. All participants, I request to log in by their name so that we can have their attendance. So for afternoon session, I would request all the participants to join by name. Some of the participants in the morning session, I've seen that they are joining with their mobile number or model number, something like that. So, and there will be assignments given after at the end of the day. All participants are requested to submit the assignments, online assignments, before the scheduled or prescribed time. So that is also one of the essential requirement of the training. So thank you very much to all the participants. I would like to thank Dr. Rajiv sir for his nice presentation. He has delivered his talk nicely on different scales of the forecast, different types of forecast, multimodal ensemble, climatic variability, and he has nicely explained how the dry and weak spells, they are active phase, from active to weak phase, they change. And I hope many of the participants, they are from the agromet group, and they will be benefited with this knowledge. So I thank you, Dr. Rajiv sir, and hope for future also collaboration with your organization and yourself in personal.
Sure.
Thank you very much. Thank you, sir.
Thanks.
Hello.
Hi.
Yes,
Okay.
Snell,
Uh,
you can end today's session.
okay, sir. With the permission of organizing secretary, I am ending this session. Thank you very much, sir. Thank you all participants.